Dear students, today we discuss about the single stage RC coupled amplifier. You know well that what is amplifier. Yeah, amplifier is the electrical and electronic circuit which used to amplify the small weak signals. The amplifier consists of the active elements and passive elements. The active elements are the transistor. Transistor is the active element. And the other passive elements, resistors, capacitors, are known as passive elements. So the amplifier consists of transistor as an active element, resistor, capacitor as a passive element. Generally, you know well that transistor consists of three terminals: emitter, base, and collector. You know well that emitter always be given forward bias, base is always be given forward bias, and collector is always be given reverse bias. The forward bias means a p-type material. For example, emitter is made up of p-type material, then the emitter is given a positive voltage. If the emitter is made up of n-type semiconductor material, the emitter is fed with negative voltage. This type of bias is known as forward bias. What is reverse bias? Reverse bias is nothing but, for example, a collector is made up of p-type material. It is fed with negative voltage. Or if a collector is made up of n-type material, negative material, n-type semiconductor, then it is fed with positive voltage. This type of bias is known as reverse bias. So, a transistor, the active element transistor, is used to construct an amplifier with emitter is forward bias, base forward bias, and collector with reverse bias. You know well that the transistor amplifier has three number of types: class A type, class B, class AB, class C, and many more classes are there. Already we have discussed what is class A type amplifier, class B type amplifier, class AB, and class C. Depending upon the characteristics of the transistor, the amplifier with the transistor allows some part or whole part of the input waveform in its output. In a class A amplifier, the class A type amplifier allows all input waveform in its output. And in class B, only half of the output is appear. And in class AB, more than half of the input waveform is appear in the output. In class C type amplifier, a part of the input waveform is appear as a output. And one more modes are available: common emitter mode, common base mode, and common electro mode. In this single stage RC coupled amplifier, it is a common emitter mode amplifier. Here the emitter is grounded. It is a single stage RC coupled. What is R? R is the resistor, C is the capacitor. So the resistor and capacitor, they are passive elements. They are used to couple the amplifier. It is a single stage. This stage is coupled with another stage. For the coupling purpose, the resistor and capacitor is used. So it is named as RC coupled amplifier. It is a single stage RC coupled. Now in this video we discuss the construction of RC coupled amplifier and the working of RC coupled amplifier and its frequency response. How this amplifier responses for the different input signal frequencies, how it is amplified, how it gives the output for the lower frequency, for the mid frequency, for the higher frequency, how it behaves, how it gives the output voltage. We will discuss detailed in this class. What is single stage RC coupled amplifier? The amplifier with the resistance R and capacitance C coupling. This type is known as RC coupled amplifier. This type of coupling, that is RC coupling technique, is employed mostly in many amplifiers. Now we see the construction of RC coupled amplifier. This amplifier consists of, the main part is the active part. The active element is transistor. This transistor is connected in common emitter configuration. You know well that what is common emitter configuration. The transistor consists of emitter, base, collector. Here the emitter is grounded. Emitter is grounded. So the base is the input. Base is the input. Collector is the output. So emitter is grounded. Base is taken as input. Collector is taken as output. So this circuit consists of the active element transistor and the passive elements resistors and capacitors. So what is potential divider? Potential divider is nothing but the combination of resistors. The two resistors R1 and R2 are used to give the biasing voltage to the base. This is known as potential divider resistor network. And the another resistor, emitter resistor R suffix E, used to give the biasing voltage to the emitter. Already I told you, emitter is always be given forward bias. So emitter is here n-type material. NPN transistor is used here. So the negative voltage is applied to emitter resistor. So the emitter through the emitter resistor. This resistor used to give the biasing voltage to the emitter and the stabilization network. And then the capacitor CE, it is a emitter bypass capacitor. It offers low reactance part to the signal. So it offers only low resistance. So it used to pass the AC signal. We will discuss in later. The load resistor RL, it is a load resistor. It is used to take the output and give the collector bias. We know well that The collector is always be connected reverse bias. The resistor RL is connected between the battery and the collector and used to provide the collector bias. On the input capacitor, it is present in the initial stage. It couples the AC signal, that is input to the base of the transistor. And the another capacitor CC, coupling capacitor, also present in this circuit. This coupling capacitor couples the first single stage to the next stage, similar transistor amplifier. So used to couple the first stage of the amplifier to the second stage of the amplifier. It also prevents the DC interference between the stages and controls the shift operating point. The first transistor RC coupled amplifier single stage gives the 180-degree phase shift in the output. There is a 180 phase shift between the input signal and the output signal. For this, the output of the first stage is fed to the input of the second RC coupled amplifier. Here, this amplifier also shifts again 180 degree, so it gives the output with 360-degree phase shift or 0-degree phase shift. Now we discuss with this diagram. This is the RC coupled amplifier diagram, circuit diagram. It consists of an active device, transistor. It is a NPN transistor. It is emitter, base, it is collector. See here, it is constructed under common emitter configuration. So emitter is grounded here. So the emitter is given a forward bias through the resistor RE. So the RE is used to provide emitter bias, the biasing voltage to the emitter. So it is CE is the also a bypassing capacitor. We will discuss about this in later. So the emitter is given a bias through the RE. Now come to the base. The base is biased with the two resistors R1 and R2. The resistor R1 and R2 is the potential divider resistors. The value of R1 and R2 decides the DC voltage. This is the 0. This is the DC voltage, the positive DC voltage. As it is connected in forward bias, it is a P material, NPN. So it is base is made up of P type material. So it is given forward bias using the resistor network and the battery. So the positive voltage is given to the base. This whole positive voltage is divided by the resistor network R1 and R2, and a part of the DC voltage is given to the transistor. This is plus DC. So this DC voltage. This voltage is varied by varying the value of resistor R1 and R2. So these two resistors produce this DC voltage here. Okay. Now we come to the collector. Here, plus VCC is fed to the collector through the resistor RC. It is a biasing resistor to the collector. The collector is made up of N-type material. A positive voltage is given. Why? The collector is always be connected in reverse bias. It is a N-type material. Here the positive voltage is given here. So it is the coupling capacitor. It couples the first stage to the next stage of the amplifier. It is a single stage amplifier. So it used to cascade, connect the different stages of RC coupled amplifier. That is a multi-stage amplifier. See here, it is the C in, the input capacitor. It allows only the AC signal to pass through it. It allows only AC signal to pass through it, and also it blocks the DC voltage from the source, from the biasing voltage source. It prevents to enter through this. So see, it does not allow this DC voltage. If the DC voltage passing through this, it will damage the signal source. So it used to protect the signal source by blocking the DC voltage from external battery. So this capacitor also known as blocking capacitor. It's also known as blocking capacitor. See here, it is a signal source. It is an audio frequency oscillator, which this signal source generates AC signal with different frequencies. It generates AC signal with different frequencies. So we know well that it is an active element transistor. They are the passive elements, resistor and capacitor, and it is the input source, signal source. So output is taken here. Now we go to the working, how it works. When the power is switched on, this resistor R1 and R2 produces a DC voltage here. See, a part of the DC voltage. It is 0.9. It is a positive DC. At the point A, this transistor, this potential divider network R1 and R2 plus VCC combinedly forms a positive DC level at the point A. Now, we are switch on the audio frequency oscillator, now feeding some input signal with particular frequency here. This capacitor allows the AC signal to pass through it. At this point, already a DC level is here. Now a AC signal is coming here. Both are combined. The AC input signal and the DC level are combined and forms the waveform like this. This is the DC level. This is the input signal. So both are combined here. Totally this is taken as positive voltage. So it is taken as a positive voltage which is passing through the base. Here the transistor amplifies and the amplified output is appear here. This amplified output consists of the amplified input sine wave. It is an amplified input signal with 180-degree phase shift, and it is a DC level. Here the positive is changed into negative voltage, minus voltage. It is DC level. It is the amplified AC level. This coupling capacitor allows only AC part. It blocks the DC part. So the amplified AC signal at the negative voltage is shifted to 0 volts here. So the output is appear like this with 180-degree phase shift. So here the negative voltage, that is the DC part, is eliminated. So we get the 180-degree phase shift amplified signal at its output. Here the same type of signal also appears here. This resistor grounds the DC level, this negative voltage, grounds this DC voltage, and this capacitor CE grounds this amplified AC level here. So the output appears only across this point and this point. So finally we get the 180-degree phase shifted output here. It is already given here. How it works? The AC signal source from the audio frequency oscillator is given to the input capacitor. The output voltage is measured by varying different input frequencies. For different input frequency signal, the output is measured. From this input voltage and output voltage, the voltage gain is calculated, and a frequency response curve. The frequency response curve is drawn between the input frequency of the signal and the gain. And see here, the frequency is taken in x-axis, the gain is taken in the y-axis. The graph is drawn like this. This area is known as lower cutoff frequency. This area is mid frequency range. This is high frequency range. This is known as mid band gain. This gain is known as mid band gain. This RMS value is taken here, 0.707 into A line is drawn. So from this point to this point is taken as a bandwidth, that is a difference of higher cutoff frequency and lower cutoff frequency. So this area is lower frequency range, mid frequency range and high frequency range. From this, the frequency is below 50 Hz, and for the frequencies above 20 kHz, it allows only this area, whereas the voltage gain for the range of frequency between 50 Hz and 20 kHz is constant, this area. So bandwidth is higher cutoff frequency minus lower cutoff frequency. From this we can calculate the bandwidth. The advantages: this amplifier provides a constant gain over a wide range of frequency. So it is suitable for the audio application. The circuit also a very simple and lower cost. It is more compact. This RC coupler also has some disadvantages. The voltage and power gain are low in some load resistance, and it gives some noise, and it has some poor impedance matching. It has some applications. They are excellent in audio fidelity for a wide range of input frequencies. That's why it is used as a voltage amplifier. Due to the poor impedance matching, they are rarely used in some final stage amplifier of some other circuits. Okay, thank you.